fraction have a 42 on the bottom, I have to multiply the top by 6 and the bottom by 6. Doesn't change anything. But now, check out what I've got. I've got 7 times 1, which is 7 over 42, plus 12 over 42. And voila! Magically, these equivalent fractions now have the same denominator. What does that mean? It means that I can just add the numerators at my whim. 7 plus 12, which is 19, over 42. And so the sum of those two fractions with different denominators actually equals 19 over 42. And what was the method? The method was to generate a common denominator. In this case, the simplest way was just to get the common denominator to be the product of the two denominators. Now, let's look at this question. Here I have 4 and 4/7, and I'm adding to it negative 4 and a half. Well, I see two mixed numbers, so the first thing I should do is to convert them into improper fractions, and that's going to allow me to add them up. So, here we go. Converting to improper fractions, not a big deal. What do? I take this 4, the whole number part, multiply it by this denominator, 7, and so then I add to it the 4 here. And so what do I see? I see 32. And I write that over the same bottom 7. And then I'm going to add, and I'm going to do the exact same process here. Negative 4 times this 2, that's actually negative 8. Well, now let's hold on here. What I want to do here is hold off that negative sign. That negative sign is there, but that's in front of everything. So we take the 4, multiply it by the 2, that's 8, and then I add the 1, that's 9, and now put in that negative sign. And that's still over 2. See that? So the negative sign we're going to hold off to until I've converted this into an improper fraction, and then stick that negative always on the numerator. Great! Well, now I've got two fractions, but unfortunately the denominators aren't quite the same, so I need to multiply the top and the bottom of this fraction by some number, and the top and the bottom of this fraction by some number, so the denominators will be the same. Again, I'm looking for a common multiple. We could look for, in fact, the least common multiple, which is the smallest positive number that has both 7 and 2 as a factor. And in this case, that least common multiple is 14. So, what do I have to multiply 7 by to make it 14? Well, 2. But if I multiply the bottom by 2, I have to multiply the top by 2. What do I have to multiply the denominator here by to make it 14? I've got to multiply it by 7, and that forces me to multiply the numerator by 7. And so now I'm converting this, but I'm converting this to an equivalent system here of two fractions. So 2 times 32 is 64 over 14, plus negative 9 times 7 is negative 63 over 14. And look, the denominators are the same by design, and so now we can just add the tops, add the numerators. 64 plus negative 63 is simply 1, and that's over the common bottom 14. So this equals 1/14. That's the answer. Neat. So there's no problem, even when we have mixed numbers, we first just convert them. We convert them to be improper fractions, and then we find a common denominator by finding a common multiple, maybe the least common multiple if you want, but always the product of the two denominators will be a multiple, a common multiple that will always work. Neat stuff. Tricky, 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 but not hard.